Good afternoon, everyone, and welcome to the channel. Today, we're going to talk about how to perform regression analysis in Excel and how to perform predictive analysis also. And the data that we have is from a company that is manufacturing three different products, and we call them Model 1, Model 2, and Model 3 in different quantities. And this column is the cost of production, and the data that we have is for 2 years, 24 months. And each line of data, okay, is the cost, we get the cost of production for 1 month. But the questions that we have in front of us, the company wants to manufacture the same three models in those quantities, okay? And they want to know how much it's going to cost to create this product. And we talk about the regression analysis, we say regression linear analysis. And the formula that want to give us that data, we, we have our dependent variable, which is the production cost. And we're trying to go through this model, we're going to determine the beta zero, which is the intercept of that linear equation. And we have model 1 x1, model 2 x2, model 3 x3. And each coefficient, you get beta 1 is the coefficient for x1, which is the slope, okay? And the beta 2 is the slope for x2, beta 3 is the slope for x3. And the way you see that, if, for instance, everything else remain the same, okay, nothing changed. If you increase model 1 by 1 unit, the cost of production Y is going to increase by beta 1. And it's the same for beta 2, beta 3 as well. So we're going to use that formula. But through the regression analysis, we're going to determine those coefficients, beta 0, beta 1, beta 2, and beta 3. Now, to be able to perform regression analysis in Excel, you have to go to data and you have to look on your upper right data analysis. If you don't see it, you have to go on file, okay? And you go to option and you go to add in and you're going to see analysis toolpack. This is an add-in. It comes with Excel, but it's not readily available. You have to install it. Excel, and you said go. You're going to have that screen, okay, that pop up, and you're going to make sure there's a check mark next to analysis toolpack. Once you see that, and you click OK. Now, our regression analysis, we want, okay, to perform it at a significance level of 95%. Okay, we want to make sure the cost, the production that we're going to forecast is valid at 95%, okay, of significance level. We want to be wrong only at 5%. Okay, to be able to perform the regression analysis, you go on data analysis and you're going to look for regression. And once you see regression, you're going to click OK. The Y is our dependent variable that we want to forecast. This is the cost of production. You're going to make sure you put cost of production. And the X are the model, different models, and you're going to make sure you take all of them. And since we put more the label, we're going to check label. And we want to have the result in the same page. And we're going to have it here. We run our regression. Okay. Now, we have the result for our regression. And you're going to see in the summary output your R square. For this regression, we get our R square is 0.45, which means when you put all three models together, they represent only 45% of the change of the variance in the cost of production, meaning there are the factors that are responsible for the cost of productions, not only those models. Okay, those three together, put together, you have 40. They represent 45% of variance. And what are the coefficient that we get from this regression? Okay, we have the intercept, which is the beta 0 over here. We have model 1, which is a beta 1. The coefficient is 1.456. And for beta 2, for model 2, it's 4.46. And model 3, you get 4.789. Okay, and the probability associated with each model, your p-value. The p-value is the probability to obtain these results that we're looking at over here, assuming that a null hypothesis is true. That means there's no change, there's nothing else. Okay, so in order for the p-value to be statistically significant, it has to be less than 0.5. And when we take out model 1, and we see we get the p-value of 0.389, which is way bigger than 0.5, which means that model 1 is not significant, is not statistically significant, okay, for this model. And when you look at the p-value for model 2, it's statistically significant, which is it's because it's less than 0.5. And we take for model 3, statistically significant, because it's also less than 0.5. Okay, and when you those are the interval. Okay, meaning each models, okay, the coefficient that we obtain over here, they have a 95% chance to be part of that interval. Okay, model 2, model 3, this is the interval. There's a 95% chance that this value is going to be inside that interval. Okay, so we have three different interval because we have three different coefficients. Okay, now see, we're going to use all three coefficients in order to calculate the cost, to see what it's going to to cost the company. We already have the result. Beta 0, which is this one, plus beta 1 time, okay, 1530, beta 2 time 1275, beta 3 time 1025. And when you perform that calculation, we get the cost. When you put everybody, all the models, it's going to cost us $98,147. Even we put the one that is not statistically significant. Now, since model 1 is not that important for that model, we're going to remove it and perform the same calculation, run again the regression with those two models. And we're going to go on data analysis. We're going to run a regression. Now, y will not change, but we're going to remove 1x from the model. Okay, and make sure the label is checked. And we're going to put the result over here. And this is what we get. We see that we have an R squared of 0.43, which means when you put those two models, model 1, model 2, and model 3 together, they represent 43% of variation in the cost of production. And when you compare that with a previous regression, okay, we see there's a difference of only 2%. Okay, but which means that model 1, that is not statistically significant, is only responsible for 2% of the variation in the cost. Okay, and that's why you see a big change in the coefficient. Beta 0 becomes bigger, beta 1, beta 2 becomes bigger, and beta 3 becomes bigger. Okay, and we perform the regression, okay, and at the 95% of the significance level. And we see that the p-value for both of them are statistically significant because they both are less than 0.05. And when we perform that calculation and we see, okay, two models together, and it's going to cost us 97,000. And we see there's a small difference between when you have both together, all three models, and only two models over here, and there's a small difference, okay, in the cost, which tells you that model one is not that important. Okay, the cost is not that big. That's why you see it's not statistically significant. Okay, so this is the way you perform regression analysis. This is also the way you are forecasting cost in Excel by using regression analysis. Okay, so and this is all I have today. And please comment and let me know what you think. And also, if you have other topic that you want me to address, please write in your comment and let me know. Also, please like and subscribe in order to help the channel. And others, the algorithm can pick up, can help me with the channel. And hopefully, and we will meet up soon and with more interesting topic. Thank you and God bless. Bye bye.